Hydroxylamine NH2OH is a strong reducing agent. When heated in aqueous solution, NH2OH reduces Fe3+ ions to Fe2+ ions. A student suggests the three possible equations for the reactions shown below. The student plans to carry out an investigation to determine which equation is correct. The method is outlined below. Stage 1. Using a pipette, add 25.0 cm cubed of 4.32 times 10 to the negative 2 moles per decimeter cubed NH2OH to a conical flask. Add 10 cm cubed of 1 mole per decimeter cubed H2SO4 to the conical flask, followed by an excess of a solution containing 0.04 moles per decimeter cubed Fe3+ aqueous. Stage 2. Boil the mixture for 5 minutes and allow to cool. Stage 3. Titrate the cooled mixture with 2 times 10 to the negative 2 moles per decimeter cubed KMnO4 aqueous. Part A. Determine the minimum volume of 0.04 moles per decimeter cubed Fe3+ aqueous that the student should plan to use in Stage 1. Explain your reasoning. Firstly, we're going to work out the number of moles of NH2OH. We're going to use volume and concentration that were given in the question, and we're going to use the equation triangle of N divided by volume times concentration, where N stands for number of moles. So using the information in the question and this equation triangle, we would do 4.32 times 10 to the negative 2 multiplied by 25 times 10 to the negative 3. That gives us a number of moles of 1.08 times 10 to the negative 3. The reason we've multiplied our volume by 10 to the negative 3 is because we're converting centimetres cubed into decimeters cubed. This is the number of moles of NH2OH. Now we want to work out the number of moles of Fe3+. We're going to use equation 3 for this question and assume that that's correct because equation 3 has the most Fe3+ ions used, and therefore by using equation 3 we're going to ensure that we have the right and sufficient amount or volume of Fe3+. If we assume equation 3, we notice that NH2OH and Fe3+ is in a 1:3 ratio. So that means we need to multiply our number of moles we've just calculated by 3 in order to get the number of moles of Fe3+. So that would be 1.08 times 10 to the negative 3 multiplied by 3. That gives us 3.24 times 10 to the negative 3 moles of Fe3+. Now we need to work out the volume of Fe3+ we need. Again, using the same equation triangle and the concentration of Fe3+, 0.04 moles per decimeter cubed. So what we're going to do this time is moles divided by concentration to find volume. So that would be 3.24 times 10 to the negative 3 divided by 0.04 and then multiplied by 1,000 because we want to convert our volume from decimeters cubed into centimeters cubed. That gives us an answer of 81.0 centimeters cubed, which we then write on the answer line provided. If we assume that equation 3 is our correct equation, then the reason why the minimum volume of Fe3+ that the student should plan to use in stage 1 is 81 centimeters cubed is because the minimum amount of Fe3+ required would be the maximum amount theoretically required to react with all of NH2OH or hydroxylamine. The marks for this question are awarded for correctly working out the number of moles of NH2OH and Fe3+, correctly working out the minimum volume of Fe3+, and writing the explanation below. Part B. In the student's titration, 21.6 centimeters cubed of KMnO4 aqueous is required to reach the end point. The equation that takes place during the titration is shown below. Analyze the student's results to determine which of the three equations is correct. Show all your working. The first thing we're going to do in this question is work out the number of moles of MnO4 minus. So we're going to use the same equation triangle as we did in part A, N divided by volume times concentration. In the question, we're given the volume of MnO4 minus, or KMnO4, and then we're also given the concentration in stage 3, 2 times 10 to the negative 2. So using these pieces of information, we can work out the number of moles. So that would be 21.6 times 10 to the negative 3, because we're converting centimeters cubed into decimeters cubed, and then multiplied by 2 times 10 to the negative 2. And that would equal 4.32 times 10 to the negative 4 moles of MnO4 minus. Now, using this number of moles, we can work out the number of moles of Fe2+. In the titration equation, we know that MnO4 minus and Fe2+ are in a 1 to 5 molar ratio. So that means we need to take our number of moles and multiply it by 5. So that would be 4.32 times 10 to the negative 4 multiplied by 5. And that equals 2.16 times 10 to the negative 3 moles of Fe2+. Using this number of moles, we can then work out the equation, or the correct equation. So we would do this using the ratio of NH2OH to Fe2+. So in part A, we've worked out the moles of NH2OH, and those number of moles were 1.08 times 10 to the negative 3. So what we need to do is then write the ratio. So 1.08 times 10 to the negative 3 to 2.16 times 10 to the negative 3. Well, that's a 1 to 2 molar ratio. And the only equation that has a 1 to 2 molar ratio of NH2OH and Fe2+ is equation 2. Here I'm just highlighting the molar ratio is a 1 to 2 molar ratio. So therefore we write that it's equation 2. To get the marks for this question, you get 1 mark for working out the moles of MnO4 minus, 1 mark for working out the moles of Fe2+, and then 1 mark for correctly identifying that it's equation 2 or working out the molar ratio. Part C. The student intends to repeat the procedure to check their results. There is insufficient time for the student to repeat all 3 stages, and the student decides to omit stage 2, the boiling stage. Unfortunately, the resulting titer is much less than the original titer. The student rejects the results from the repeated procedure. Part 1. Suggest the purpose of the boiling in stage 2 and reasons for the second titer being much less than the original titer. For this question, we first need to say that boiling speeds up the reaction. And if the reaction is sped up, that's going to mean that there's going to be less Fe2+ produced, and therefore the second titer will be less than the original titer. To get the marks for this question, you get 1 mark for saying that boiling speeds up the reaction, and your second mark for saying that there's less Fe2+, or linking back to the question. Part 2. The main reason for insufficient time is the need to boil and cool the mixture for each titration. Suggest how the procedure could be modified so that stage 2 does not need to be carried out repeatedly. Give your reasoning. How the procedure could be modified so that stage 2 does not need to be carried out repeatedly is that we modify stage 1. So that means we're going to, in stage 1, increase the quantities so that there is sufficient solution for more than one titration. In order to get the mark for this question, this explanation or statement must be written on the answer lines provided. In stage 1, increase quantities so that there is sufficient solution for more than one titration.